So taken my initial readings and counted out how many I've got. So I've got a total of 38 of these connectors, and amazingly I've got 35 screws. So that means I can use every single one in this fashion. What I'll be doing is one piece of wire per connector on the others. So you can see I've got multiple pieces of wire, which is okay. That doesn't affect the performance. But for this I'll just use one at a time and then separate them by a certain amount of degrees, so the displacement of them is even, and there's no crossing wires, and no way they can affect each other by crossing down the path, which is an important part of what I learned on the radials a few weeks ago. Initial results on the Vita, you can see there, it's already really good SWR readings, but we must understand the SWR readings are just one part of the antenna's performance. SWR shows that it's matching well, or say it's resonant on those frequencies, and it matches so the antenna can see it. Does it make it a good antenna or not? Who knows? So that's what we're doing here. We're investigating on how to increase the antenna's performance. You have to say the 6BTV has done me well so far. I've made contacts on 40 telephony, and data modes, 20 no problem, 80 no problem there with data. I've got loads of screenshots which I'll be putting on my blog as I write this up, but I think the next thing for me to do is maybe I can do that as we're here now. Let's get a Smith chart up. It's got so many cool tools on it. Let's do a Smith chart. Click OK. There we go. So what's that set to? 27,500. That's going to be like 11 meters. Now I need to change that. Let's see, we can't change the frequency quick. There we are. Brilliant. Fantastic piece of equipment. You could. I'm not saying I'm trying to discredit the Nano VNA here, but look how easy this is to operate. So I want to change the frequency, say to, I don't know, 80 meters. That's the highest band that this antenna is tuned to be resonant on. So let's go to 80. Press function. Select 80 and then click OK. And it just does the business. It's so nice to work with, it's so clear. Look at the display on that. So let's have a read, see if I can make anything of these as I understand it now. So the little square is there, so that ties in with the SWR results. I need to look up again, understand the radial, sorry, not the radiuses in the Smith chart. But there's an initial result on 80 meters. Yeah, it's all good, I'm sure, but we'll do more and more tests. Let's do another one on 20 quickly. Have a look at the grass. The ants having a party. Let's do one on 20. There we go, we got one on 20 there. And what are the results there? 1475. That'd be a frequency I use quite a lot, 20 meters. I use it for SSTV and making telephony contacts. And I do use the end fed for most of my telephony work on the TS690. Get some use from it, and it's just a nice rig with telephony. But anyway, focusing on the 6-speed TV, yeah. Here's our Smith chart currently with no additional radials down. What other reports have we got? We can use RX chart, never used that before. Let's have a look, see what she says. So that's looking at 1475. I don't quite understand these results whatsoever. There we are. I think what I'm about to do, maybe if I've got the inclination, is to do this in the shack, but I think it's important to do the measurements from the antenna and not just the coax as well. I know it forms a part of the antenna, but I'm not quite sure what that means. So we've got X 16.94 and Y at 50.9. So I'm figuring R is resistance and X is inductance. I'd need to check. Anyway, it's another good result, and another, you know, this AA555 zoom is a fantastic piece of kit. I just need to get the most out of it. We touched on it on the field day, and we saw some really interesting things. So I'll need to go back to my ARRL book and see what I do. But here we are. I'll continue with putting down more and more radials. This is the current. I haven't put any more radials on there yet, so I've just got the first one to put down. Fairly fiddly. There's a lot of work on the ground here, so I have to roll them out, then pin them down, and then tighten them up. But really like, look at the quality of the workmanship from DX Engineering. It's just brilliant. So you got like a compress washer, what's that, a star washer, a regular washer, then a compress washer which goes on the top of it. So I'll be putting this at the bottom, obviously, not the top. And then tightening it up, so the tightening is from the top, which is where you can see all the washers, and that bolts underneath on the underside of the radial plate. Usually I can get away with just using my fingers and holding it. That's usually tight enough. And I think it's an 11 meter, a size 11 spanner on the top to tighten it up. Yeah, that's what I'll be doing next. Get the first radial out, which will be where the hole is now. I'm gonna go. I think what I'll do is I'll go north to south to start with. Got a lot of space going north, that's for sure, and limited space going south. So yeah, let's see how we go. Let's do that north south first. Sounds a plan. 2 Echo 0, Foxtrot with the Echo. Bye for now.